ఇక్కడ ఇక్కడ బుక్ తెచ్చుకోలేదా నువ్వు? సైన్స్ బుక్ తెచ్చుకోలేదా? What is the focal length? Focal length. Say loud. Say loud. Yes. This is the core. This is the. What is center of curvature? What is center of curvature? This surface is there. This is surface of mirror. This is the surface, na? Means outer layer. Okay. Surface area of reflecting. This area will have reflection. Na? It will form one sphere. Imagine here it is forming that sphere. Which one? This reflecting area, reflecting surface of a spherical mirror forms a sphere. Reflecting surface, this is the reflecting surface. This is forming one sphere. Whole, not only here, this whole thing is forming one sphere. Okay. That sphere will have one center. Suppose imagine here. This is called C. Reflecting surface of a spherical mirror form a sphere. Okay, repeat with me. Reflecting surface of a spherical mirror. This is spherical mirror, concave mirror. Concave mirror, right? This will form a sphere. It will have a center. That is called the center of the curvature. Center of the curvature. Okay. What is radius? What is R? This is P. R. What is R? Radius. I told you. Radius. Right? This PC is there. Distance distance between the center of curvature and pole. Distance between the center of the curvature and pole is called R. What is focal length? Huh? Suppose there are parallel lines falling on the mirror. Okay. These are the rays falling on the mirror. Again, this incident rays will again reflect, no? Will reflect. Okay. And they meet at one point. They meet at the one point on principal axis. What is mean by principal axis? Principal axis means a line passing through the center of the curvature and point. Okay, this is called principal axis. On the principal axis, this all meet at one point. This is called, that point is called focal length. Principal focus. Principal focus. Okay. The distance between pole and the principal focus. Okay. Pole and the principal focus is called the focal length. That is represented by F. That is represented by F. The distance between pole and the center of curvature is called radius. The distance between pole and the principal focus is called focal length. F. What is the principal focus? This incident rays will reflect and meet at one point. They are reflecting rays meet at one point. That is called principal focus. Okay. So, are you clear with this all terms? Again, what is principal focus? Abhinav, what is principal focus? You come friend, Abhinav, you are not concentrating. Come friend, sit here. Don't read. When I am taking class, your subject only. If you read, how? Come friend. Concentrate here. Don't sit there. Come here. For sitting also, how many times you call? Sit here. Don't sleep. What is principal focus? Abhinav? What is principal focus? Reflecting rays meet at one point. Okay, that is called principal focus. What is focal length? Saranya, what is focal length? C and P is called radius. Radius. Focal length, small f. Focal length we denote it with small f. Okay. The distance between principal focus and the pole. This is called focal length. Okay. Now we are going to discuss today. This already many times I discussed. Once I revised it. Now, if you see the representation of image, how will you represent it? That we completed. And learn a sign convention. Okay, sign convention for reflection by spherical mirrors. Sign convention. Sign convention of what? Reflection by spherical mirrors. Reflection by spherical mirrors. Okay. Concentrate, you will get problems here only. Problems will come from here only. Okay. Concentrate. If you don't understand, ask me. I will tell. Okay. Concentrate more. While dealing with the reflection of light by spherical mirrors, we should follow a set of sign conventions that is called new Cartesian sign conventions. New Cartesian sign convention. Okay. We should follow some rules to draw the image of the image. Okay. To draw the image, we should follow some rules. Who gave that rules? Means new Cartesian sign convention will say how to draw that one. We should follow that rules. What are those rules? One by one we will start here. Okay. The pole P of the mirror is taken as the origin. This is the origin. We know this one P. This is concave mirror. Okay. This is the origin. We take the P. What is P? Pole. Okay. The principal axis of the mirror is taken as the x-axis. Principal axis. What is principal axis? A line is passing through the center of the curvature and pole. One line is passing, that is called principal focus. Principal focus P. Okay. This is P. I am taking in x-axis. In x-axis I am taking. This side x dash of the coordinate system. The conventions are as follows. The object is always placed to the left of the mirror. Suppose here I am keeping this mirror. Okay. This is in front of me. This mirror left side means where will you get this side? This side. Okay. Means always you should keep the left side of the mirror. Left side only you should keep the object. That is one thing. Rule number one. What is rule number one? The object is always placed at left side of the mirror. Okay. Next, this implies that the light from the object falls on the mirror from the left hand side. Okay. This means that this implies that light is falling from left hand side. If you are keeping the object left hand side means, okay, the light will fall from left hand side only, na? Suppose, imagine, this is mirror. Okay, you stand up again. You keep like this and this is concave mirror, right? Like this you will keep. Concave mirror means inside it will have. This is the mirror, like this is. This is the mirror. Okay. Now you keep straight like this. No, like this only. You keep this. Now this is the object you imagine. This is the object. Where I should keep? Left hand side. Left hand side means this side, na? This side. This is left, na? This is left side. This is right side. Left side I should keep the object. So rays from the book, this object will fall from left side only, na? Not from right side. On the mirror surface, from which side the rays will fall? Left side only. Okay, what is the rule number 1 in the new Cartesian sign convention? Always keep the object in left hand side, so that the light rays will fall on the mirror left side only. From the left side only, light rays will fall on the mirror. Okay, are you clear with this first point? Okay, sit down. All distances parallel to the principal axis are measured from the pole of the mirror. Okay, wherever that image will form from the object, image formation, how we are measuring? From the pole only you will take. From the pole only distance, focal length, center of the curvature, radius, all these measurements we will do now. Where is the first point? Which one you should consider? Pole only you should take. From the pole only you will measure everything. Suppose image is formed here. From where will you measure? Will you from here? No. This is the pole, na? Center. Okay. So from here only you will measure. Suppose center of the curvature is here. Will you measure from here? This distance? No. From the pole only you should measure. This is second point. All distances will be measured from the pole only. Okay. Coming to the third point. All the distances measured to the right of the origin are taken as positive, while those measured to the left of the origin along the x-axis are taken as negative. Okay, positive, negative. This is the main thing. Okay, from value you will get negative, positive. The image is bigger or larger, you will come to know the sign, positive sign or negative sign. Okay, here also all the distances measured to the right of the origin, okay, positive only. This is the right side, the origin is this one. Origin means where this reflected rays are coming back. This is the origin. Right hand side is positive values. Okay, this is the left hand side. This is right hand side. This is left hand side values are negative. From the origin, right hand side are positive values. Left hand side are negative values. Left hand side are negative values. All the distances. Suppose the image is formed here. Right side. Imagine this is the trick. Okay. Image is formed this side, right side. That means positive only, na? Positive only. Distance you will measure from P to F. Suppose here it is formed. You will measure from here to here, na? That means value is negative, negative, negative. Positive and negative. Okay. So, all the distances measured to the right of the origin are taken as positive, while those are measured to the left hand side origin are taken as negative. Okay. See, in the concave mirrors, it will form front side. Front side. In the convex mirrors, image will form back side. Okay. So, if it is right side, it is positive. It is left side, the values are negative. Okay. So next, distances measured perpendicular to the above the principal axis are taken as positive. This is perpendicular, left to right over. Okay. Up and down. These are perpendicular values, like this. If you see, above values are positive. above side if you see. Down side if you see, measured perpendicular to the below the principal axis are, these are actually this value is perpendicular. No? Suppose if you imagine this is y and y dash. Okay. This will taken as upward, taken as positive values. Downward you will take it as negative. Negative values. Next. The new Cartesian sign convention described above will be this illustrated example. These sign conventions are obtained to obtain the mirror formula and solve related numerical problems. Okay, sign conventions will help. So, mirror formula, what is mirror formula and what is magnification? Magnification, the size is this much. The size is this much. If you see in the mirror, it will be this much magnified. That means becoming big. That is called magnification. Becoming big. Okay. How much it is magnified when compared to the real object? When compared to the real object, how much it is magnified? We can also measure that. Okay. So, if you see that magnification, from here only we get the problem. Okay. Now we are here with the new Cartesian rules. Okay. How we are representing, how we should take the values. If it is left hand side, if it is the distance is right hand side, how we are measuring, we came to know. Now this magnification, how much it is taken object, so that we will discuss now. Okay. See, in a spherical mirror, the distance of the object from its pole is called a object distance. Okay, ma? This is there, na? This is the mirror. This is the concave mirror. Here is a pole. Pole is a part of the mirror, right? Pole is a part of the mirror. Okay. The spherical, the distance of the object from its pole to the object distance. This is the principal axis. A line is passing through the center of the curvature, and the pole is called the principal axis. What is principal axis, Charanya? A line is passing through center of the curvature and pole. Okay, this line is passing through both. This line is called principal axis. Okay, this is the mirror. Suppose if I keep the object here, from here to here, the distance is measured from pole to object. Not only any object you take. We are calling it as object. Okay. From pole to object, this is the object. Listen carefully. Now I will ask you the questions. Okay. From pole to object, distance, whatever it is there, the distance is called the object distance. What do we call? Object distance. We are denoting with the U. What is U, Amma? It is the object distance. It is the object distance from object to pole. Whatever the distance is there, suppose it is 20 centimeter is there. How much is there, paper? 20 centimeter. Then U is equal to 20 centimeter. U is equal to 20 centimeter. Okay. You are clear with U now? What is U, Abhinav? డిస్టెన్స్. ఆబ్జెక్ట్ కి పోల్ కి మధ్య ఉండేటువంటి డిస్టెన్స్ ని మనం ఏమంటున్నాము? u. Object distance. Object distance. The distance of the image from the pole of the mirror. From the pole of the mirror is called image distance. Suppose after falling incident rays, they are reflected, and suppose imagine that image is formed here. Image, just a point size. That image is formed on the sheet. Okay, on the sheet, image is formed here. Okay, this distance is there. This distance is called image distance. We are denoting with V. Object distance is U. What is U? Object distance. What is V? What is V? Image. Image. This sun will be appear as a spot, right? That image. That is called image. Na? This is called, this point size is called image. This sun is appearing on the sheet as one dot. This is called image. Whatever this distance is there between image and pole, this distance is called image distance. Image distance. Okay, there are two terms. Observe carefully. Object distance. Okay, image distance. Image distance. Okay, object distance and image. What is the object distance is denoted with u, and image distance is denoted with v. Okay, we know already what is focal length. What is focal length? Focal length. Whatever this object is there, this will be falling on the mirror. Okay, they all meet at one point. They all meet at one point on the principal axis. Okay, this is called focal length. Right? This u, v and focal length will have the relationship. Okay, you already know that the distance of the principal focus of the pole is called focal length. The distance of the principal focus from the pole is called the focal length. This is the principal, this is center, this is here, this is called principal focus. Okay, this distance is called focal length. This distance, image distance and object distance. This three, u, v and f. These three are having a relationship. Okay, there is a relationship between these three quantities given in the mirror formula. Okay, that is only called a mirror formula. What is mirror formula? 1 by u v equal to plus 1 by u equals to 1 by f. This is the mirror formula. Very, very important. Very, very important. You will be asked questions based on this formula. Very, very important. What is the formula? 1 by v plus 1 by u is equal to the 1 by f. 1 by f. Okay. What is the formula? can apply this formula. Okay, so you want to see the new Cartesian sign convention by substituting the numerical values of the R and R in the mirror. So in which with this values you should write. Okay, that sign convention you should do. In which mirror they are saying, image where it is formed. According to that you should write the negative values to positive values. Then that value should be right here and calculate. You will get the magnification. That is okay. Mirror magnification you will get it. Okay, magnification produced by spherical mirrors gives the relative extent to which the image of the object is magnified with respect to the object size. It is expressed as the ratio of the height of the image. It is the height of the image by height of the object. This is object H. Height H we are denoting with the height. Magnification is denoted by small n. Then small n equals to H dash by H. This is magnification formula. Okay, the magnification m is also related to the object distance and image distance. So object distance we can relate it. H dash means that is image height, na? So v, and image height is means u, v by u. Okay, so you may note that the height of the object is yes, we know the height of the object. It is upwards positive. It is downwards means negative. Principal axis upside means positive. Downside means negative values you should take. Okay. So the height of the image should be taken as positive for virtual images. This also you should remember. The height of the image should be taken as positive for virtual images. Actually, height of the object is taken as positive, na? Okay. Height of the image is taken as negative. The object is usually placed above the principal. The height of the image taken to be as positive. However, it is to be taken as negative for real images. For real images, height, we are taking it as negative. Remember, the height of the image, real image, object will be there, na? The height of the, it is to be taken negative for real images, negative. Real images. You should by heart this one because we are not doing experimentally. So you have to by heart. Real images, negative. Okay. Real images, negative. Height of the object taken to be positive as the object usually placed above the axis. The height of the image should be taken as positive. For virtual images, positive. For virtual images, positive. So height of the object is always positive only because we are keeping it as above the axis, principal axis. Suppose if you get the value here negative, okay, negative sign value, image is real. Okay. If you get positive, this image is virtual. Virtual. You will get value now when you keep the values of v and u. Some value you will get. If it is negative value, image is real. If the positive value, it is virtual. Whether it is image is real or virtual, they will ask question. Okay. One problem they will do it. You will come to know. Okay. Convex mirror is used for rear view on automobiles. Has a radius of curvature 3 cm curvature. C they have given in the problem. Okay. What they have given in the problem? C. Center of curvature. C. How much value they have given? How much value they have given? Center of curvature. C is 3 centimeter. Read the problem. Understand the problem. A convex mirror used for rear view. Which mirror they are using, Amma? Convex mirror they are using. Okay. Center of curvature, it is not centimeters, they meters, 3 meters. If a bus is located at 5 meters, that means object. Bus is object. Bus is object. Okay. That is called U. Object means U. Na? Image means V. Okay. U, how much they have given? 5 meters. Center of the curvature is here convex mirror. Na? So, like this. Convex mirrors. Okay. So, image will be formed back side. Right. Bus is here. The bus is here. This distance pole is here. This distance is how much they have given? 5 meters. 5 meters they have given. Okay. So image where it will form? It will form back side. Na? Image will form back side. Okay. That means this is the front side. Means what are the values? Positive or negative? Left side? Positive. Here are negative. Left side right charging here. The distance measured right of the origin are taken as positive. These are positive. These are negative values. The right side of the origin. Okay. Those measured to the left of the origin are taken as negative. This left origin, these are positive. Only image is formed this side, right side. Because it is a convex mirror. Okay. So, find the position, nature and size of the image. You should find the position. Where is the position? Where is the position, Amma? Where it will form? This is pole. Okay. Here is the center of curvature. They have given 3 centimeters, 3 meters. Okay, this distance is how much, Amma? 3 meters. Okay. And first, image size. You should also find the height. What is focal length? First, we should find out the focal length. F you should know, na? If you know the F distance, you will come to know. So, focal length is R by 2. F equal to R by 2. What is R? This is R, na? P and C. Distance between pole and C is called R, na? How much they have given? 3. 3 by 2. 3 by 2 means 1.50. 1.50 meters. Okay. I will take the values as positive. Why? Because they are right side. If they are left side, I will take negative this value. but it is right side, that is why I am taking it as positive values. Okay. So convex mirror, behind the mirror. Okay. We came to know F and U also they have given. What is the formula? 1 by U plus 1 by T plus 1 by U, that is equals to 1 by F. Right? Substitute the formulas. Okay. If you take this is a positive and here. Okay. This is positive value. If you take it right side, it will become negative, right? We want 1 by B. 1 by B equals to 1 by F minus 1 by U. This entire thing I am keeping this side. Side will change. Okay. Positive will become negative. So minus 1 by U. We know the F value. What is F value? What is F value? 1 by 1.50. Okay. Next. Minus 1 by minus you will get. Okay. If you do this, if you solve this 1 by 1.50 plus 1 by 5, you will get it. If you do the LCM of 1.50 and 5, you will get 7.50 by 6.50. That is equal to 1.15. That is 1.15. Okay, if you do the LCM of this problem, you will get this one. So 1.15 meters. Okay. So it is the value positive. So the image is 1.15 back side the mirror. Okay. V is 1.15. Your mother can know it is becoming late. Okay. Once you do practice formula, tomorrow we will solve many problems on this formula. You will get problems for it. Remember what is the formula? 1 by B plus 1 by U equal to 1 by F. Okay. If you want to find out the focal length, R by R equals to what is the focal length? To find out focal length formula, R by 2. R by 2. We will do tomorrow problems on this. I will say what is image. Don't write all that. Write in the tuition book. Tomorrow I will solve 10 to 15 problems based on this formula. You will understand how to identify the size, position, nature. Okay, they will only ask us. This is only they will ask in the exam. Now we need to find out position, size, nature. We will solve previous year questions also. Okay, we can do. Tomorrow after doing the problems, we will start the refraction of light. In your textbook, the refraction is there. You can do it. Not to start अभी master ये आपको आ गया एक बार